Well, hi everyone, this is Bob the Science Guy. In our last episode, we talked a little bit about vectors and we talked about what's called the unit vector, the IJK system of describing vectors. Remember, this is the x vector, that's the y vector, and that's the z vector. And we talked a little bit about adding vectors together. So, for example, if we add these two vectors from our last example together, we get vector c will equal 11.928i plus 12.66j. And from that, we were able to find the length of the resulting vector and the angle to the x-axis. And of course, if we want to subtract these vectors, we do it exactly the same way. Recall that if you write down vector a minus vector b, we are subtracting vector b from vector a. Likewise, if we write down vector b minus vector a, we are subtracting vector a from vector b. And that does make a difference because, as you can see, for example, here on this first one, if we subtract b from a, we end up with a positive 1.928i. If we subtract a from b, we have a negative 1.928i. So it does make a difference what order you do this in. Let's look at something called the dot product. The dot product is the multiplication of like vectors. So let's just put down multiply like vectors. Now what do I mean by that? So let's take our vectors from above. We have VA 6928 plus 4J, and VB is 5 plus 8.66J. If you have two vectors and they both lie in the same direction, so we have vector A and vector B. If we multiply these together, we get vector C, which is the magnitude of vector A times the magnitude of vector B, and we get the resulting vector is the product of A times B. If we look in the y direction or the j direction, and this is 3 and that's 2, what we're going to end up with is a vector of 6, of magnitude 6. However, if we try and multiply a vector 2 in the y-axis or the j-axis by a vector 5 in the i-axis or the x-axis, this does not equal 10 because these are not in the same direction. This equals 0. Let's go see why that is. All right, a dot product is you're multiplying two vectors together. Specifically, you're multiplying like by like. So what you're going to get here, what you'll get here is 6.928 times 5, and that will be your I value. And then you're going to have 4 times 8.66, and that will give you your J value. But when you're dealing with two vectors that are perpendicular to each other, or orthogonal, you have 3i times 0i equals 0i. You also have 0j times 5i, or 5j, and that again is 0j. So the answer is 0. Now I used I and j here just to kind of illustrate what we're doing. Now there's an interesting relationship that you'll see in the book, and that is that the dot product between two vectors equals the magnitudes of the vectors multiplied together times the cosine of the angle between them. Well, what if you're not given the angle between them, but you are given the magnitude of the vectors as we were here? So what we know is by calculating the dot product, we know that 69.28 in this case equals 8 times 10 times the cosine of angle theta. And if we take 69 divided by 80, that equals the cosine of theta. So bring out our trusty calculator again. Let's do second cosine to get the arc cosine function, and we'll take 69.28 divided by 80 and see what that equals. 30 degrees. And that's pretty much all I wanted to talk about as far as dot products went. So the purpose of the dot product is to get you a value that you can in turn use to calculate the angle between two vectors. Now in the next episode we're going to talk about a different type of multiplication, and that's called the cross product.